Hello students, in your last class you have gone through the various division procedure, and today's topic is remainder theorem. Before going into the remainder theorem, we go through the various examples of division again. Okay, let's take suppose uh, 13. If I want to divide a number 13 by 2, okay, so what we will do, just simple division. 2 6 are 12, so answer will be 1. Okay, remainder will be 1. Over here by the number this number 2 is called divisor, and this 13 is called dividend, right? And what you can say, 6 is your quotient and 1 is remainder. Okay, so now when we put up these numbers together, right, that means how we were getting this 13. So when we go to for this, that means we can write 13 as 13 equals to 2 into 6 plus 1. Okay, so that means we can set up the relation as dividend equals to divisor into quotient plus remainder, right? Suppose if you are asked to divide a polynomial 2x square minus 3x plus 6 by x minus 2. Okay, so what we will do, we will solve this. How we will see the first term, that is of the dividend 2x square, and that of the divisor is x. So how much I have to multiply with the x in order to get 2x square, that is 2x. So therefore what you will get 2x square, and we will divide multiply this minus 2 into 2x. The minus is over there, therefore your answer will be 4x. okay, so we will change the sign, and when we solve this, 2x square minus 2x square will get cancelled, and the answer that you will get is over here, that is x, because the 4x is the greater number with having the plus sign. So therefore x plus 6. Now what we can see that now x plus 6 will be the new dividend. We have to divide it by the divisor x minus 2. The first term of the dividend is x, and of the divisor is x as well. So that means I have to multiply with 1, that is plus, I have to multiply with plus 1. Okay, so therefore your answer will be x minus 2. Now we will change the sign again. What you will get, this x and x minus x will get cancelled, and 6 plus 2 we will get is 8. Okay, that means the remainder is over here. This is the remainder, and you got the quotient as 2x plus 1. Okay, we have seen two examples. Do you find any important points? We can say that if we divide polynomial x by divisor, suppose it is x minus a, then the remainder will be f of a. Okay, this is remainder theorem. That clear? Now we will go to prove this theorem. uh, Now how will you prove? For that you should know the relation between this dividend divisor. Okay, we will use that concept only. Let's prove. Now we know the concept that we know that dividend equals to divisor into quotient plus remainder. Yes. Now over here let's just consider dividend as per our theorem. As we know that our dividend is f of x, and divisor we have taken to be x minus a, and our quotient is suppose q of x, and I am taking remainder to be r. Okay, so now the value of f of x, finding the value of an polynomial you have already studied in your class 9th. So therefore the value of f of x is follows when x equals to a. That means the value of this x will be a, is because our divisor is x minus a, right? So therefore what we will write is just therefore now we can say that f of a equals to, substituting the value of x, it becomes a minus a into q of a plus r. Okay, therefore f of a equals to a minus a becomes 0, and q of a plus r. Therefore we can say that 0 into q of a is 0 plus r. Therefore f of a equals to r, where r is the remainder. Therefore we can say that if we divide a polynomial f of x by x minus a, then remainder will be f of a. This is the proof of remainder theorem. Now by using the remainder theorem we can find remainder without doing division, if we know the dividend and divisor. Now but before that we should know the two very important points, which I am writing it over here. When divisor is equals to x minus a, then remainder will always be f of a, that we have already studied in the above theorem. But what about when divisor is equals to x plus a, right? So in this case the remainder will be f of minus a. Always keep this in mind. I am repeating again. When you divide any polynomial by x minus a, your remainder will be f of a. But when we divide the polynomial by x plus a, then the remainder will always be f of minus a. You should always keep this in mind. These 2 points you have to always keep this in mind. Okay, now let's solve some examples related to the remainder theorem. We will use the previous examples only that we have taken up before when we begin this chapter. The example was p of x equals to 2x square minus 3x plus 6. That is, this is the dividend, and the divisor was given as x minus 2. Now, as we are using the remainder theorem, what does remainder theorem says? When a dividend is divided by, suppose the dividend is f of x, and we divide f of x by x minus s, then the remainder will always be f of a. So therefore, over here the remainder will be, let's solve, remainder will be p of 2. As I said earlier, what we told, when the divisor is x minus a, then the remainder will be f of a. So therefore, remainder over here is p of 2. Okay. So therefore, we can say that 2 into 2 square minus 3 into 2 plus 6. We are doing nothing but substituting this value, that is 2, in place of the variable x, that is our dividend part. Okay, now we will solve this one. Then what you will get when you solve this, 2 square is 4 into 2 is 8 minus 3 into 2, you will get 6 plus 6. Therefore, this minus 6 and plus 6 gets deducted, and what will remain is only 8. That is, our remainder is 8. So students, I hope this concept is clear to you. So I will give you some homework. You have to solve this, and if there is any doubt, please feel free to ask